everybody. Yeah, in this particular video, I'll be explaining about the field test on DC series motor. So basic theory behind the field test, and then we will see how the procedure has been carried out in the virtual lab. And we'll also discuss about the difference between the procedure that is being done in the virtual lab and also the procedure that we follow in our lab. Okay. So starting with the theory part, the main purpose of conducting the field test is to find out the efficiency of the DC series motor. Now for any machine, in order to find the efficiency, like how efficient the particular motor or machine is, there are two types of tests that we conduct. One is predetermining the efficiency and second one is just determining the efficiency. Now this particular experiment is not predetermining the efficiency, it is determining the efficiency. Now the difference between predetermining and determining the efficiency is, under predetermination, no load is connected on the machine. You run the basic tests that you conduct, due to which you can calculate the losses in the machine, and using those losses for required load we can calculate the efficiency. Now there is no actual load connected under predetermination. Now coming to determination of the efficiency, there you connect an actual load on the machine and then you give certain input, you calculate the output and you calculate the efficiency. Now in case of DC series motor, you cannot conduct the conventional load test that we do on DC shunt motor. Such tests cannot be conducted on DC series motor. Now the answer is because in case of DC series motor, you cannot make it run under no load condition. That is the one of the biggest disadvantage or limitation of DC series motor. You cannot make it run under no load condition. If in case you happen to run it under no load condition, the speed of the machine can become dangerously very high, which will lead to mechanical instability, or you can say which is very dangerous to the person who is working on that particular motor. So always we have to make sure that the DC series motor is not run under no load condition. Now the conventional load test that we had conducted on the shunt motor normally requires that you start the motor under no load condition and in steps we increase the load. But the same setup cannot be used for DC series motor because there is a procedure where you make it run under no load condition which cannot be applied to DC series motor. So now for that reason we conduct field test. Now here what we are doing, now coming to this field test, you are taking two series machine. They are two identical series machine. Now you are mechanically coupling the two series machine. Clear. Now there are two conditions that you have to keep in mind under mechanical coupling. First one, both have to be equally excited. The excitation of both the machines should be same. That is, the current in the field winding of both the machines should be equal. That is the first condition. Second condition under mechanical coupling is you have to make it run under same speed. Now since it is mechanically coupled, you cannot take two different speed machine. You have to take two machines such that they have same rated speed. That is the reason why we go for same speed machine. This first thing, why are we going for equal excitation? Now the reason behind going for equal excitation is the iron loss of both the machines should be equal. That is the reason why we go for equal excitation. So out of two machines, one machine is made to run as generator and one machine is made to run as a motor and other machine is made to run as generator. So there is a small mistake here in the slide. One machine is made to run as motor. Okay, this should be machine. One is made to run as motor and other is made to run as generator. And output of the generator is utilized for some load R. Now here we say it is to be wasted on some load R, because you cannot, unlike Hopkinson's test or regenerative braking, you cannot make use of the output of the generator here. So it is simply a wasting that output on some load R. Now, in this particular virtual lab setup, before the starting of the experiment, some amount of load is kept on, so that you can avoid no load running of the DC series motor. And in steps, you keep on increasing the load and note down the various reading. Now, coming to difference between actual lab setup that we use in our lab, in our department lab, the first thing is, whatever starter we use in our lab is rheostatic starter. But here in virtual lab, they have used 3-point starter. So coming to rheostatic starter, we all know that there will be a starting rheostat, there will be a variable rheostat, or you can say armature rheostat and field rheostat. So there are rheostatic starter will be used. And next thing is, in our lab setup, the procedure that we follow, we normally start the setup with maximum load. First, before starting the experiment, we make sure that all the load is kept on. The whatever our load is there, that will be kept under maximum condition, and we run the motor at rated speed. Then in step, we start to decrease the load. Now this is different from what procedure that is followed in the virtual lab. There you start from the minimum load and increase the load in steps. In our lab setup, we start it under maximum load, and in steps we decrease the load and corresponding meter readings will be taken. So that is the difference between the lab setup that is there in our department and the lab setup that is used in the virtual lab. So coming to the virtual lab, so this is the lab setup. Yes. Now coming to this lab setup, this is the circuit diagram that is followed here. So you can see that. So in order to make sure that both the machine have equal excitation, you can see the field windings are connected in series. That is, the field winding of the motor is connected in series with the field winding of the generator. That means both the field windings have, this makes sure that both the field winding will have same amount of current flowing through it, due to which you will get equal excitation. So field windings, this field winding, that is motor field winding, and generator field windings are connected in series, so that you can have equal excitation, and both the machine armature are mechanically coupled, and they use a 3-point starter. So this is the armature voltage of the motor, and this will give you the armature voltage of the generator. So this is the theory. I'll just skip this part. Now coming to apparatus used, the instruments are the voltmeter, tachometer, ammeter, and resistive load. And coming to object under test, now here you are actually testing DC series machine. So next, this is the circuit diagram, and if when you scroll down, you can find the nameplate reading. So both the motor and generator, you can see that the speed rating is same, whereas the voltage and current rating, you will not find equal rated machine. That is very difficult to get identical machines. So this rated speed is same, but there is a small difference between the voltage rating and the current rating, because it is very difficult to get the identical machines. So next, this is the procedure. So here you can see the connection is done as per the circuit diagram. A minimum load of 400 watts. That means that when you have this particular load, there are different switches, individual load switches will be there. A minimum load has been turned on. Okay, and then you switch on the DC supply and close to DPST. You start the motor, keep the DC voltage constant at 220 volt. You make it run at the rated speed, and then increase the load until the rated value of the armature current. Now here, we don't make it run under rated speed. We only switch on the supply. Now in step, we keep on increasing the load current. or the load such that we reach the rated value of the armature current. Now coming to the armature current, the rated value of armature current is given as 13.6 amps. Now 13.6 amps is the armature current or the generator current. So we increase the load until we reach this particular value. And then for different we increase the load in steps and note down the reading, and then we reduce the load. After that, be keeping minimum load, we switch off the supply. So this is the procedure that we follow. So here there are certain precautions, so I'll just skip. So coming to the procedure part, here you can see that just click on the connecting wires. The system software, within the virtual lab will do the entire connection. So this is the 3-point starter. So you first both the from the supply you connect it to the 3-point starter, and from the 3-point starter you start connecting it to the different setup there. So this is the setup. So this is armature terminals of the motor. This is our field terminals of the motor. Similarly, you can see the armature and field terminals of the generator. So yeah. So once this is the setup, and this is the 5 kilowatt load, so you can make sure that it is showing the load has to be kept on, the minimum load has to be kept on. You can see this notation which this indicates that it is kept on. Now you can click on the supply, so you will switch on the supply, and then the DPST is closed. Clear? So once the DPST is closed, so you will start the motor by using 3-point starter. So now you can note down the no load readings. You cannot say it has to be no load reading. It is the minimum load reading. We cannot call it as no load reading because the load is kept on. Now here the highlighted part is indicating to switch on another load. So we'll switch on the we'll click on this. So the next set of load is added. Now you can see the respective ammeter reading, voltmeter reading, and speed readings are noted down. Next, again, I'll click on this highlighted part. So the next set of load is being added. So then again, the different meter readings are noted down. So this is continued. So continue the experiment for different values of load up to the rated value. So now this is the actual procedure that we do in the lab. Sorry, this is the coming to the lab, experiment that we do in the lab. We keep it under maximum load. It means that we will switch on all the load and then we start the machine. And then in each reading, we'll keep on decreasing the load and we take down the motor reading. So that is the actual procedure that we follow. Now, after finishing taking all the readings, we'll keep on reducing the load until we reach the minimum load value. Not all the loads are removed, only keeping minimum load on. Rest all load switches are switched off. And then we open the DPST and then we switch off the supply. So this is the procedure. Now, if you want to like if you are not clear with the procedure, you can just click on this reset button, and that way again the entire simulation part will start. So provided we know, I'll just so next I'll click on next button. Now here you can see uh, different calculations have been done, and those calculations are tabulated. Now, armature resistance, series field resistance, armature resistance of the generator, and series field resistance of the generator. They are the given values. Uh, Using these values, the entire calculation has been done, and this is the motor voltage. This is the supply voltage. This is the generator voltage. As you keep on increasing the load, you can see that the generator voltage starts to decrease and motor voltage is also decreasing. Clear? And you can see the armature current is increasing and the motor current is also increasing because you're increasing the load. So for these values, you can see the generator output, motor output is calculated, and through this the efficiency of both generator and motor is calculated. So you can see that as we've seen in our lab setup, the generator efficiency is found to be greater than the motor efficiency. Like for this particular reading, you can see that the motor efficiency is 83%, whereas the generator efficiency is 87%. So based on these values, the values are calculated. Whatever results are there, the efficiency versus output graph is calculated for both motor as well as generator. So this blue line is for the generator, and the green line is for the motor. So this is the graph you get. I request all the students to take the screenshot of this particular graph, or no need to take the screenshot of this particular graph. Using the values, plot the graph on your own. So take the observation from here. Use these readings, do the calculation on your own, and then plot the graph. So this is the inference. The first thing is we are keeping some load on during that is initial load is kept on, so that you can avoid high speed of series motor. That is the first thing. Second thing, as the load increases, the speed of the motor decreases. Though we have actually in this particular virtual lab setup, you can see the speed was not noted down, but actually speed decreases as you keep notice it in different experiments. Next, so because of this particular application, you have very high initial torque in case of series motor. So always DC series motor are used for large load industrial application, which requires heavy starting torque. High starting torque, if the application requires high starting torque, then we normally go for DC series motor. You cannot use DC series motor under constant speed application, because as you change the load, the speed of the machine changes, which is a limit. So due to which you cannot use series motor for constant speed applications. So these are the different Viva questions. So that's it. Thank you.